Welcome back, dear students. This video is the last one we are going to study on statistical correlation and regression. In our previous video, if you may recall, we studied certain basic introduction on regression, starting with what we mean by regression, types of variables that are used. Then we learned about regression lines, and we learned about regression coefficients, certain properties of regression coefficients. We are going to apply all of them in these problems here in this particular video. Let's begin. Let's read the first question now. From the following data, evaluate the regression coefficients, correlation coefficient, regression lines, most likely marks in statistics if marks in economics is 30, and most likely marks in economics if marks in statistics is 45. So we are given a table of values of 10 students who have secured so many marks in economics and in statistics. And basing on this table, we need to evaluate all these 5 components. So let's first of all denote the variable x to represent the marks in economics and y to represent the marks in statistics. As we require the mean values of x and y in our formulae, we shall first evaluate and then see what kind of method we could apply. Is it the direct method or actual mean method or the assumed mean method? In fact, any of them could be applied, but for a simpler case, let's analyze it further. So x bar is sigma x by n. So we have added all the values given to us divided by the total number of observations. So it's 320 by 10. So it gives us 32. Similarly, the mean value of y, which is y bar, adding up all the values of y, dividing it by n gives us 380 by 10, which is 38. We see that x bar and y bar are both integers, and we can as well use the actual mean method by subtracting all the given observations from 32 and 38 and then using the corresponding formula. So I have used the actual mean method here, but you could also use the assumed mean method or the direct method to evaluate further, because we want the regression coefficients, which is bxy, byx, correlation coefficient, which is rho, and our regression lines, which we are aware of, and then find out these two unknowns. So let's use the actual mean method as I'm showing it here, but the method you could choose as you wish. So as I said, since the mean of x and y are integers, I have adopted the actual mean method here, and I have taken the deviations of x from the mean, which is 32, and called it small x, and taken the deviations of y from the mean of y, which is 38, called it small y. So when we take the deviations from the mean, we get summation of x and y to be 0. That's one check that we are right. So let's check that first before we go into square and multiply. And then we proceed with the squaring of x values, getting its total, squaring of y values, getting its total, multiplying the x and y values and getting the total of the product xy. So we make use of these three summations in order to find the regression coefficients, and that's shown in my next slide. For the actual mean method, our bxy, the regression coefficient, is nothing but sigma xy divided by sigma y square, because we find that sigma x and sigma y both are equal to 0. So it's just sigma xy by sigma y square. We have substituted the values based on the table values. We have got the value of bxy. We see that it is negative. And similarly, byx, denominator will be x square. Here bxy, the denominator will have y square, and we are dividing it by sigma x square. We get another negative value for byx. Note that the sign of bxy and byx should be both positive or both negative, because that's the sign which defines the sign of the correlation coefficient. So these are the two regression coefficients as we have defined here. Now the correlation coefficient, which is our next question, is for rho square. When I multiply bxy and byx, I am sure you all remember byx is equal to rho times sigma x by sigma y, and Byx is equal to rho times sigma y by sigma x. So when we multiply Bxy and Byx, we find that a sigma y, if you want me to explain it by writing it explicitly, into rho times sigma y by sigma x. So I see that sigma y gets cancelled, sigma x cancels, and therefore you get rho square is equal to Bxy into Byx. So I'm multiplying by using these values here, Bxy and Bxy, and then I multiply it to get a positive value. I calculate the square root of it, and as I said, the rho value, the sign of rho will either be plus or minus and depends upon the sign of Bxy and Byx. Since here Bxy and Byx both are negative, our value of rho is also negative. So we have rho is equal to minus root of 0.1552 is 0.3939. So the value of rho is this. If you have seen my previous video, we have done using one of the methods in order to get the same rho using the direct formula that we have derived. But here we are deriving the same result using the regression coefficient. So your answers coincide. Coming to regression lines, the regression line of x on y that we have is x minus x bar equal to bxy into y minus y bar. I'm sure you know that bxy can also be written as rho sigma x by sigma y. But why I have not written this and I have written bxy is because I know the value of bxy directly. So I can substitute it. So we have substituted for x bar is 32, y bar is 38, bxy is minus 0.2337, and I have simplified it in order to get an equation of this form. So this is regression line of x on y. In a similar manner, we shall find the regression line of y on x. So in the same manner, I have written the regression line of y on x as y minus y bar equal to byx, because I know the value of byx in my, as we found out directly, and I have substituted for x bar, y bar and byx in the similar format, simplified in order to get the regression line of y on x. So that was my third part. So the first part was regression coefficients, second part was correlation coefficient, and the third part is the two regression lines which we have got in as a linear equation. Now, the fourth question was to find out what is the most likely marks in statistics if marks in economics is given to be 30. We have assumed that the marks in economics is x and marks in statistics is y. So the question says find the value of y when x is equal to 30. Meaning when y is required to be found, we use regression line of y on x. So I take this equation which we have derived and I replace that x by 30, simplify it to get the corresponding value of y. In the same way, if I want to find the most likely marks in economics, like marks in economics, we have called it x. If marks in statistics, that is y, is given to be 45. So in order to find x when y is 45, we use the regression line of x on y. So we have framed the equation earlier just prior in the previous slide, and in that we replace y by 45. So I replace y by 45 and simplify, I get the corresponding value of x. So we have now found the regression coefficients bxy, byx. Then I found the correlation rho. Then we framed the regression lines basing on all these. And then we have found, in fact, before itself we started with x bar, y bar, and then we found out y value when x is known, the y value that we had to frame when x is known, and we had to find the x value when y is known. So we have done almost the entire regression in one problem. So a very important problem this is. But as I told earlier, we could either use the assumed mean method or the actual mean method or the direct method. I have used the actual mean method. The reason being the x bar y bar values, I found them to be integers. So it was easier for me to calculate the differences. Though we are using calculators, the decimals could be avoided. So I assumed it to be the actual mean method. But you could also try out the other methods. The answers should be coincide. Let's now see problem number 2. The following data here gives me the heights of father and son in centimeters. So we have to find again regression coefficients, correlation coefficient, regression lines, and also predict the son's height if father's height is 154 centimeters and the father's height if son's height is 176 centimeters. So it's a similar question like the previous one. So height of father is given for 8 people and height of son again for 8 people. So we have denoting x to denote the height of father, y to denote the height of son. So I'm calculating x bar, y bar as we did in the previous problem. But here we note that the values of the means are not integers. So I am not using the actual mean method, but using the assumed mean method. Since I have decimals, when I take the deviations, I naturally will have to handle decimals, and therefore to avoid that, I am assuming the assumed mean method in this particular problem. But again, as I say, it's up to you and what you find is comfortable, but kindly note that the results should coincide. So I have constructed the table for the assumed mean method. What is the assumed mean I have chosen for x? I have chosen 160. I have chosen assumed mean for y is 159. So I have calculated the deviations. So I get sigma dx, sigma dy, sigma dx square by squaring the dx values, sigma dy square by squaring the dy values, and by multiplying dx dy I get sigma dx dy. So this table you're already aware. We are doing that similar problem. Though x bar, I have not used x bar y bar as they contain decimals, but there is no such restriction. I have used it only for my convenience. For the assumed mean method, the regression coefficients will be bxy is equal to capital N is the number of observations, sigma dx dy minus sigma dx into sigma dy. This is the numerator for the correlation coefficient also. But denominator in correlation coefficient, we have square roots, but all that is not there. Since I am talking about bxy, the denominator will simply be n sigma dy square minus sigma dy the whole square. So this part occurs in the denominator with a root. But the root does not exist, the second term is not there. So it's even more simpler. All the values are obtained from the table and I calculate bxy to be 1.68. Similarly, byx, the numerator is the same, but noting that since I am calculating byx, x is independent variable, so the denominator will contain only x terms. I have simplified and I have found byx. Note that both bxy and byx are positive, meaning the correlation coefficient should also be positive. So we are calculating rho square by multiplying the two expressions. And because I have plus or minus, and so knowing that both are positive, I choose rho to be plus the root of this 0.9408, which is 0.97. So this is the correlation coefficient. Then I similarly calculate regression lines. So here x minus x bar is equal to bxy into y minus y bar. We know x bar, we know y bar, we know bxy from here. I am substituting and developing a relation or an equation which we call it to be the regression line of x on y. So in a similar manner, I calculate the regression line of y on x as y minus y bar equal to byx into x minus x bar. Very simple because all the values are already known to us. We substitute it, we rearrange the terms and write it of the form y is equal to something times x into the constant term. So we have got the regression line of y on x. Now the first question that he has asked us to find is to find the value of y when x is 154. So when I'm given that x is the value which is 154 and I need to find the value of y. So I'm finding the regression line of y on x. When y is known, I need to find y on x. I mean, x is known, I need to find y. Similarly, to find value of x when y is given, I need to use the regression line of x on y. So I simply take the given that equation which we derived, I substitute the given value in it, simplify, get the answer. So it's exactly similar to what we did in the previous problem. The only difference that we have seen is because it was x bar and y bar were integers, I used the actual mean method in problem number 1, And here, since I found that they are not exact integers, I used assumed mean method. That's the only difference, but otherwise the way of calculation is exactly similar and easier, much scoring type of problems these are. Let's now see the problem 3, which reads this way: find the most likely price of a product in Bombay corresponding to the price of rupees 70 at Calcutta from the following data. The correlation coefficient between prices is given to be 0.8. So we are given the price of a product in two cities. One is Bombay and Calcutta. So let us take X to denote the price in Bombay, Y to denote the price in Calcutta. So what are we given? Rho is given to be zero point 0.8 from the given data. Okay. Now he has given you a table here which says average price. What does average price mean? Average price in Bombay, which we have assumed the notation as X, it means X bar. Average itself means mean. So X bar equal to 65. Similarly, Y bar equal to 67. Rho is equal to zero point 0.8. Standard deviation. Standard deviation is denoted by sigma. So sigma X meaning standard deviation of that price in Bombay is 2.5. So sigma X is 2.5, sigma Y is 3.5. So we are given in terms of rho, sigma X, sigma Y. So please note the formula that we have done. Last two problems we wrote BXY, BYX. So here we are going to use this formula which we have already learned, but we are only recalling here because we are given rho, sigma x, and sigma y explicitly. So the first question that we want to know is find the most likely price in Bombay, meaning find the value of x, find x when you are given y to be 70, when the price in Calcutta is 70. So when I want to frame value of x, I use the regression line of x on y. So it is enough if I frame that equation alone. So let me write down that equation first. So I know x bar, I know y bar, I know rho, I know sigma x, I know sigma y. So where is the question? And now y value is given to be 70. So that also I know. So I will substitute everything, simplify, get the corresponding value of x, which is the price of the product in Bombay. So very, very simple formal problem it is because we know all the data that is very explicitly given to us. So the notation for standard deviation is sigma and the notation for average is x bar, y bar. This is sigma x, sigma y. So using that results, we have framed the answer. So let's now read the last question. The two lines of regression are, there are two equations given to us. Find the mean of x and y, that's the first question. Correlation coefficient, that's the second question. And they find the variance of x, given that the variance of y is 4. Now variance is the square of the standard deviation. Its standard deviation square. So if sigma is denoted by for standard deviation, then sigma square is the variance. So if I write sigma x square, it means variance of x, and sigma y square is the variance of y. By taking the square root of the variance, you get back standard deviation. We are given that the two lines of regression are these two equations, but we are not given which is regression line of x on y, which is regression line of y on x. That's not explicitly given to us. So it's a trial and error process because there is no mention about what kind of equation it is. Now, so I have chosen here, let the regression line of y on x, because I have y on the left hand side, I have taken y on x to be y equal to x plus 5. So when I know the equation is of this form where y depends on the value of x, the slope of this line, which will be byx, because this is the regression line of byx, will be the coefficient of x when the coefficient of y that is occurring on the left hand side is 1. Please note that the regression line of y on x is assumed to be the first equation. So when I do that, then I write down the slope of the line, regression line of y on x, which we denote by byx, What is it given by? It's given by the coefficient of x. When will I take the coefficient of x? When the coefficient of y that occurs on the left side should be 1. So what is the it's already 1 here. The coefficient of y is 1. Yes, it is satisfied. So the coefficient of x that we take should be the slope, which we denote by byx. So byx is 1. Now I assume the other equation to be the regression line of x on y. It's only an assumption that we are taking. So because I have 16x on the left side equal to 9y minus 94. So what is the slope of this line? It is bxy. How do I find the slope? It will be the coefficient of y when the coefficient of x that occurs on the left hand side is 1. So when will it become 1? When I divide by 16. So this is actually x is equal to 9 by 16y minus 94 by 16. So this is the kind of equation I have. So what will be the slope? The slope of this line will be the coefficient of y when the coefficient of x that is occurring on the left hand side is 1. Yes, we have divided by 16 to make it 1. So now what is the slope bxy? It is 9 by 16. So we have got both the slopes. One is the regression coefficients, which is bxy and byx. Now we shall multiply the two to get rho square, that is by our formula. So when I multiply, it's 1 into 9 by 16, so it's 9 by 16 that I get. And rho square is 9 by 16. Obviously, rho will be 3 by 4. There is no concept of plus or minus here because both bxy and byx are positive. So rho is 3 by 4, and that confirms that rho is 3 by 4, and it also confirms that our choice of the lines are correct because the rho value should always be less than 1, and 3 by 4 is certainly 0.75, which is less than 1. Now you may ask, why not take the other way around? What would happen if I take the regression line of x on y to be the first equation and y on x to be the other equation? Then what will happen? Will I get the same row? Let us check it before, because we have taken the first guess itself and that has worked out. So suppose I take the regression line of x on y is y is equal to x plus 5. So what are we writing this as? X is equal to y minus 5. Okay, so now this is the regression line of x on y. So I'm keeping x on the left side. I have rearranged the equation and written it as y minus y 5. And so bxy now becomes the coefficient of y when the coefficient of x is 1 on the left side. Yes, it's correct. So bxy is 1. Now come to the second one, regression line of y on x. What is y on x? Actually, we assume that equation to be 16x is equal to 9y minus 94, or you rearrange it, you get 9y is equal to 16x plus 94. Now, what is the slope of z? We are having y on the left side and x on the right side. So this is the regression line of y on x. Now I want the slope, that is byx. What will it be? It is the coefficient of x when the coefficient of y is 1. It's not 1. So what I do, I divide by 9 and make it 1. So what is byx now? It is 16 by 9. Now I have calculated slopes of both the equations that I assumed. Multiply the two, what will rho square be? It is 1 into 16 by 9. It is 16 by 9. So can I say now rho here therefore is 4 by 3, and is it possible? It is absurd because this is greater than 1, and we know that the rho value cannot be greater than 1. It always lies between minus 1 and plus 1, and therefore our choice of the equations is wrong. That is the choice that we made, that the first line is regression line of x on y is wrong. So what is the correct one? We don't have to do both. It's enough if we check once, and if we see that rho value is less than 1, that means our choice of equations is correct. I have shown you the other way around just to tell you that you may start with this and you may find that rho is greater than 1 and then finally judge that the choice of the two equations is wrong and get back to the stream. So it happens. So there is no other process but trial and error. So we have got the value of rho here. So this correlation coefficient we have found first. What is you mean? How do you calculate the mean of x and y? We have studied in the properties of regression lines that the point of intersection of the two regression lines gives us the mean coordinates. So therefore, if I want to find the mean values, I simply have to solve them simultaneously. So I have to solve it as simultaneous equations. I eliminate x, find y, I eliminate and substitute back to get y. Here I have eliminated y first by multiplying the first equation by 9 and subtracting, so I get x value. And then I substitute it back in one of the equations and get the y value. So the values of x and y that I get stand for the mean values. So I write that as x bar and y bar because of the property that the two regression lines intersect at the point which represents the mean coordinates. So that's where I get the mean of x and y, and then I find the correlation coefficient. Now let us find the last part. Now, in the last part, we have to find the variance of x given that the variance of y is 4. So, as I told you, the variance is the square of the standard deviation. So, I am given the variance of y. So, variance of y is given to be 4. So, when I take square root with a positive sign, sigma y here is equal to 2. So, which I have represented here. Now we can either take byx or we take bxy. You can take either of them because we know both. And because byx contains rho, sigma y, sigma x, so I know it to be equal to 1. So I equate it to 1, of which I know the value of rho is 3 by 4, which we have found already. Sigma y from the given condition is 2. I need to find the variance, sigma x. So I see that this is standard deviation. So standard deviation is sigma x. So I simplify it. I get sigma x here to be 3 by 2. So therefore, what is sigma x square? Because I want the variance of x, not sigma x. Sigma x means the standard deviation of x. I square both sides and get sigma x square to be 9 by 4. So that's my result for the last part of this question. So dear students, I am stopping the chapter with this and not giving, you can try out some more problems from this, all similar types of problems. And correlation and regression forms the most significant part of statistical analysis because correlation gives us how closely two variables are related and regression tells us what is that close relationship that we are developing. So two very important topics but quite easy to score in the marks point of view also. So kindly work on them, and if you have any doubts, kindly you can put them in the chat box or even you can call me or talk to me and we shall clear the doubts as and when you get them. So we complete the unit and we go to the next unit, which we call it as design of experiments, and I shall bring out a series of videos even in that chapter, just as we did about 7 videos for this chapter here. So see you once again in the next unit. And please keep practicing and trying out problems continuously until you perfect yourself in these topics. So good wishes. Bye for now.